The current laser technology, we are using the standard semiconductors. Standard semiconductors are mostly 3-5 semiconductors. That one of the deleterious things of this system regarding the sustainability point of view is that we need high temperatures in order to obtain these systems. If we are looking for sustainability and to reduce the environmental impacts, it's very important to reduce for example, the temperature of the different processes. In SUPERLASER, we are trying to do that with a new systems, relatively new perovskite materials that are also semiconductors, but they are possible to make by solution processes, decreasing enormously the temperature of synthesis. And then this is very important because we are decreasing a lot what is the energy input that we need in order to prepare the devices. Allied perovskite materials, perovskite is not a concrete material by itself. Perovskite in fact just is a crystalline structure. Then there are many different materials with this perovskite structure. The ones that we are looking for, because they have a very excellent optoelectronic properties, especially because they have a very low non-radiative recombination, are allied perovskites. The ones that they are obtaining the highest performance are the ones that are based in lead. The problem of lead is a toxic material. Then for the beginning, for the starting of the technology, it's interesting to use these lead-based perovskite materials because are the ones that are going to highlight or are going to establish where are the limits of the technology. But in parallel to the use of lead perovskite, in SUPERLASER we are working also with the other less lead-free perovskites, as for example tin-based perovskite, with the idea to decrease the toxicity of the systems. Recyclability, it's a very important part of the final scope of the project. Another of the good points of prepare a system that is based in solution processes or solution synthesis at low temperature is that these systems are also very easy to recycle, because we don't need very high temperatures, as for example is required in another semiconductor technology in order to try to recycle the system. At very low temperatures, with low energy demanding and cost demanding processes, we can recycle the systems. And then this is very important also for the circular economy, because the idea at the end is to have a product that it's sustainable and it's very basic for the sustainability point of view is the recyclability.